Okay, we have one last thing we are going to do, and again, we are in section 3.3, which is solving our systems of inequalities. In example 3 here, example 3a, we are going to solve a nonlinear system of inequalities. And that just means that in my two equations that we are working with are two functions, not both of them don't have to be linear. So example 1a, we're solving our nonlinear system. And my first example, let's do y is less than -3 times the absolute value of x plus 3 plus 1. And then my second inequality, y is greater than or equal to -x minus 5. So we're revisiting our absolute value function and our transformations that go with. So first thing, I'm going to draw in my x and my y axis. And I'm actually going to start off graphing our linear function here, just because that's a little bit easier to work with. Y is greater than or equal to -x minus 5. My y-intercept is -5. And my slope is -1. So down 1 over 1, down 1 over 1, and then I'll come back this direction also. Since my symbol is greater than or equal to, I'm going to use a solid line to connect my dots. And again, greater than means we are going to shade in the region above. Okay, my top function, the absolute value, y is less than -3, absolute value of x plus 3 plus 1. We have a lot of transformations that happened here. But remember our process for making our table of our parent function, our table of values. We start off with our parent function, and the absolute value of -2 is 2. Absolute value of -1 is 1. And this will be 0, 1, and 2. Adjust our values accordingly. So remember also that our transformations follow the order of operations. We have to start inside first. This plus 3 is going to move our graph left, which means we have to subtract 3 from each x value. Our multiplication next, we have our negative, which is a reflection over the x-axis, and our 3 times, which is our vertical stretch. So I'll do the negative first. Reflection over the x-axis flips upside down. It affects our y values. That 3 again is a vertical stretch, which also affects our y values. And then last, this plus 1, that's going to take our absolute value function, which is upside down now, and move it up 1, again affecting our y values. So add 1 to each y value. And these are my new values to plot. So -5, -5. -4, -2. -3, 1. -2, -2. -1, -5. And since my symbol is just less than, we use a dotted line or a dashed line to connect your dots. Less than, we shade below. So this problem, our solution is pretty small. It's our double shaded regions, just like before when we had linear systems of inequalities. Our double shaded region is our solution.